Are we skipping number 5 on purpose? I think 5 are just too open-ended. Compare writing equation when the pattern in the table shows a common difference versus... Yeah, we're skipping. Well, I mean, you can answer it if you want. I just thought it was going to be redundant. Can we quickly go over how to identify independent and dependent variables? Independent variables. What you control. Dependent variables. What you measure. As an effect or affect. I don't know. What you control. Other words, these are your inputs. These are your outputs. These are your x values. These are your y values. This is your domain. This is your range. I don't know how many of these words you know to make it easier for you. Dependent depends on your independent. Does that clear it up at all, Eli? I know you were asking a bunch of questions yesterday and I wasn't coming up with the right way to explain it to you. But is there homework? Yeah, I think there's a... Did I tell you to do a page? I don't know if I told you to do a page or not. There might be. I'm not looking at the assignment right now. I was in the middle of bringing everything up. Yeah, I gave you homework. I think it's like 4 problems or something. Test. Okay, for number 1 on the test, you have to look up some information. I didn't give it to you. So I will give it to you now unless you want to look it up. It's asking how many inches are in a football field, or it's telling you 100 yards. So you want to turn 100 yards into inches. Okay, yeah, we will. You want to turn 100 yards into inches, so you need to know how many. You need to know that there are 12 inches equals 1 foot, and 3 feet equals 1 yard. These are your 2 conversion factors that you need to know. That's a 12. And 12 inches equals 1 foot, and 3 feet equal 1 yard. Is that enough for you, Anna? I'm saying okay. I was not planning on doing the homework together, Gianna. I was planning on telling you, it's not a hard assignment. It's pretty simple, actually. I'll give you some examples and then you can do it. Independent and dependent variables. I don't know. What do we got? Do some examples. I'm just going to look up science project ideas. Maybe. See what I can find. Yeah. Here's a sentence. See? So independent and dependent variables really come and play in science, to be honest. In math, we're going to start calling them X and Y, domain, range, input, and output. They're going to get a lot easier to pick out once you read context and stuff. It's going to take some practice, I guess. So one group of students studied with the TV on, another group is studied with silence. Students were then given a quiz to check understanding. This part here, whether you studied in silence or not, study in silence versus not silence. You have control over that. You choose who goes into those groups. You are picking that. You choose what kind of not silence it is. This here is your independent variable. Once you do your assessment of things, you measure something. You're going to measure based off of that quiz. So the quiz is a measurement that you take of the effect of this. This would be your dependent variable, right? You are looking at whether noise affects study. So noise would be your independent variable. That's what you control. Quality of study would be your dependent variable. Yeah, we're going to go over how to do the homework, Lyra. In fact, we're going to start now. Eli, if you have more questions, we can hang on after we're done with the lesson here. But it's pretty simple. It's a little wordy at first, but it's not too bad today. I want to be able to write, so I can write, right? Yep. Okay. So you're going to get questions that are similar to this. You're going to be seeing a table of sorts, and it's going to organize information. So you're going to use the table to identify the relationship between, in this case, number of guitar lessons and the total cost. So which one here is the dependent variable? Here's another example, Eli. Number of guitar lessons, does that depend on the cost, or does the cost depend on the number of guitar lessons? And I can see how you might get a bit confused depending on your perspective of that. But if you are someone who is buying guitar lessons, the number of lessons that you buy is going to dictate how much you pay. It's not the other way around in that sense. You're not going to be like, hey, I have $30. How many guitar lessons can I get? because $30 might not even be a good number for guitar lessons. You might not have a number of guitar lessons you can get for $31. In fact, this one isn't, you're not going to, because each guitar lesson here, well, I mean, if you look at it, it's not too difficult, but each guitar lesson is going to be $25. So you can't get a guitar lesson for $31. It doesn't exist. You can get one for $25 and then have some change, and things like that. What about harder ones like 226 number 3? Is that the page we're on? I don't even know what page we're on. So 226 number 3. Gus Jada, 145 tickets to the amusement park at this rate. Yeah, your independent variable. That's the I sent you this. Your independent variable equals, what was that? What's going on? Equals your number of tickets, and your dependent variable equals the cost. It's the same as this. How many guitar lessons do you want? How many tickets do you want? It's going to depend on the cost of it. It's just a little different context. And if you were to graph this or something, you'd be like, hey, I want 1 ticket, 2 ticket, 3 ticket, 4 ticket. 1 ticket costs, well, in this case, we'll do this one, 25, because I know what it is off the top of my head. One will cost $25, right? And there's your plot. What is it? 2 would cost $50, 2, and then 50 would be up here, right? And you get a line, however it works. You're going to get into a lot more of functions in the upcoming years. They're going to be one of the first things that you look at when you get into algebra. They really dictate pretty much all of the world around us. It's all about relationships between different things. And depending on the context, what's actually happening, right, you're going to determine how much your trip or your guitar lessons cost based on how many lessons or how many tickets you buy to the place. It's not going to depend on the money you spend. Right? The money depends on the cost. You do not have control over the cost of the product. That's somebody else's job. Right? You can't go to Disneyland and be like, well, I mean, I guess you could haggle and stuff like that, and you can probably talk people down to things, but I mean, the advertised price tends to be the advertised price. That's what something's worth. You don't decide the worth, the market decides the worth, and so on. Of course, you play a part in the market, and you might have a little influence over things here and there, but so on. Say today's. Yeah, that's today's stuff. We'll do it today. It's not hard. You'll be able to do it after we're done with the examples here. So here we want to use the table to identify the relationship between guitar lessons and the total cost. We've already identified that this here is your dependent variable and this here is your independent variable. Right? Number of guitar lessons is going to determine the cost. Right? If I buy 2, then I spend 50. If I buy 5, I spend 125. Describe the relationship with words and an equation. So what it's asking here, this part here is what's new. Describe the relationship with words and an equation. It's asking, how do I go from my independent variable to my dependent variable? How do I go from 2 to 50? What do I do to 2 to get 50? In this case, your book is really pigeonholing you into two approaches right now. You're going to be picking between 2 things. You're either going to be adding or subtracting, which we know is really the same thing because they're inverses of each other, or you're going to be multiplying or dividing, which again are the same thing because they're inverses of each other. They really do the same thing depending on how you word it, right? I can add a negative instead of subtracting a positive. I can divide the reciprocal, or I can multiply by the reciprocal instead of dividing by the fraction, or dividing by the whole number, so to speak, right? So they do, I mean, you've been playing with them paired together all year. I mean, even in order of operations, plus and minus are at the same level. Multiplication, division are at the same level. Yes, there are other operations in math. You might have square roots. You might have exponents. You might have logs. You might have, I don't know, cubed roots and stuff like that. There might be a whole bunch of different ways to go from 2 to 50. You're pigeonholed in this lesson to either be adding or subtracting or multiplying or dividing. You're not going to be doing both. It's going to be one or the other for this lesson. When you get more into functions and more into algebra, algebra is actually a tool invented to make this stuff easier. So right now, due to the fact that we don't know much algebra, it's kind of guess and check. But when you get into algebra, this is going to be easier once you use the tools you learn in algebra. That's one of the reasons why we have algebra. That's one of the reasons why algebra is so important and why algebra is such a great thing, is because it can identify relationships really easily. Here we got to do some guess and check. If it's going to be addition or subtraction, it is going to have something called a common difference. Okay? And that would be saying that, hey, when I take my independent variable, well, actually, I want to do it the other way. You want to take your dependent variable and subtract from your independent variable. So to find a common difference, you're going to take your dependent variable and subtract your independent variable from it. That way, when you write the equation, it's actually going to be the inverse of that. So you'll be like, okay, what am I adding to 2 to get to 50? What do I add 5 to get to 125? So you're going to go through each of these and you're going to subtract them and you're going to find that common difference. So here we're going to do 2 minus 50. I'm sorry, 50 minus 2. Right, because you want your dependent variable first. And that's going to equal 49. Here you're going to do 125 minus 5. And that's going to equal 120. And you'll note that this number and this number are different. That's what you're looking for. Because a common difference would say they are supposed to be in common. So this one is not going to be an addition or subtraction relationship. It's going to be the multiplication or division one, right? Because this was not true. So your book is going to have you check for this, and then it's going to have you check for this. See which one is true, and then write it as an equation. And we'll do a couple examples so you can see what it is. It's getting kind of wordy right now. But here, this is what's going to be called a common ratio. Do they call it a ratio or a quotient in your book? I don't remember what they call it. They call it a quotient. It's a ratio, but whatever. It's a common quotient. So in this case, you're going to take your dependent variable and divide it by your independent variable. And what do you get here? Right, if you take 50 and divide it by 2, you're going to get 25. So here we're looking, I'm going to write it below if I have room. Right, our dependent variable, which is 50 divided by 2, gives you 25. And you'll note that 125 divided by 5 also equals 25. And you'll note 150 divided by 6 equals 25. You'll note that 200 divided by 8 equals 25. And you'll note that all of them are 25. In this case, you have a common quotient, which means how am I going from your independent variable to your dependent variable? Well, you're multiplying it by 25. right? 2 times 25 is 50. 5 times 25 is 125. 6 times 25 is 150. 8 times 25 is 200. So then you're just going to pull it out and make it an equation. You're going to take your independent variable, which we're going to call G for guitar lessons, and your dependent variable, which we'll call C for cost. You're going to take your guitar lessons and you're going to multiply it by 25, and that's going to equal your cost. So this here would be couldn't you subtract and then notice a pattern in the differences? Yeah, then it would be addition or subtraction. I'm confused by your question, Neil. This would be your equation. We don't write it like that, though. We put coefficients in front of variables. This would be C equals 25 times G. And then it wants you to write it in words, so it would be the cost equals 25. I'm going to write the number out. 25 times the number of guitar lessons. Right. When is this due? If you can get it done by next Friday, that would be great. I mean, it's really not a difficult lesson once you get rolling. Right. So you're looking for a common difference or a common quotient. Once you have that, your relationship's probably going to be the inverse of it. So if we get a common quotient, it's going to be a multiplication relationship. You take this number and multiply it by this number, or multiply it by your common difference or common quotient, and you'll get this. We'll do another one here. We'll clean this one up and move on to the next example. Right. So this one here says, I'm going to move this out. You don't need to look at that. Right. The volume of juice, which we're going to call J, so that's over here, that's J, a restaurant puts in a glass depends on the size of the glass. So which one is the dependent variable and which one is the independent variable? Well, it tells you that the volume of juice here is going to be your dependent variable because it depends on the volume of the glass, right? You can't put, you can't decide, oh, I don't know, you can't have a glass and be like, hey, this glass here holds 26 fluid ounces and decide, hey, I'm going to put 32 fluid ounces in there. That doesn't make sense. You're going to determine how much you can put in that glass based on the volume of that glass. If you want to write it down, you can, Catherine. I don't know if we're going to do another test or not. When we're done with this lesson, I'll go over Amanda. But here you have the glass size is going to be your independent variable, and your glass volume is your dependent variable. I didn't leave myself much room. I'm going to put in this column here. This is your independent variable. This is your dependent variable. Again, this is your x and this is your y if you want to get used to doing it. That way you can sit there and imagine putting this on a graph or something. This would be your x coordinate, this would be your y coordinate, and your ordered pair would be 6, 4.5. So first you're going to check for a common difference. So subtract them. 4.5 minus 6 equals negative, I lost my calculator, didn't I? No, I'll use a fancy one. I mean, you can probably do that in your head. I'm just getting tired already. Is that coming up? Show calculator, just so we can see it. There we go. Right, so you can do 4.5 minus 6 And you get a negative 1.5, so negative 1.5. And then you're going to check to see if that's true with all of them. So here we'll do 10.5 minus 12. Hey, that equals negative 1.5. We'll do 14.5 minus 16. That also equals negative 1.5. So we have a common difference here. All of these have a common difference of negative 1.5. Once you find that, you don't have to find the common quotient because you know it's not going to be there. It's going to fit one case or the other. This one fits the common difference, or a common difference is negative 1.5. So how do we go from 6 to 4.5? Well, we did 6 minus 1.5. There's your negative 1.5. Or, because it's a common difference, technically it would be 6 plus negative 1.5. But then you can clean up your signs. And that's how you get to 4.5. So our relationship from going from glass size to volume of juice they put into the glass is going to be, I guess we'll call this G. You could call it X because we already named it X, and we'll call this J because it already named it J. So in order to get the amount of juice you put in, you take the amount, the glass size, so the G of it, and you're going to subtract 1.5. And that's going to equal the amount of juice you put in. And that holds true for all of these. If I were to take 6 and plug it in for G, it would be 6 minus 1.5. I would get J, which is 4.5. If I do 12, 12 minus 1.5 equals my 10.5. Right? So I plug in G and I get out J. And it's a relationship between the two. And with this information, you can sit there and be like, hey, what if I had a glass that was 72 fluid ounces, right? Well, then I would take 72 minus 1.5 and I would get, what is that? 70.5 fluid ounces of juice. So you can sit there and you can actually figure out any size you want because this is dependent on that. And it will tell you the other one. Any questions? Am I missing something? So notice something between 49 and 120. Is that the last one? Right, you're asking, how do I go from my independent variable to my dependent variable? How do I go from my x to my y? Not too difficult. Let's bring up the next one. Where all my layers went off to. Hey, there's one. I don't know if this was the next one I was going to do or not. But here we're given a table. You're given shoe size versus running shoe size. Again, you're going to sit there and you're going to identify which one depends on the other. X is normally going to be on top, independent variable and dependent variable. Right? So this here is a relationship. This is one of those confusing ones that Eli might be asking about because you can technically have the inverse of this too. But how do we go from this to this? Hopefully you should be realizing there's a common difference between that. In this case, again, check for a common difference. So do 55 minus 5 equals 0.5. 6.5, 7 minus 6.5 equals 0.5. You'll note that I could subtract the same amount between them. So what I'm going to do is I'm going to take my shoe size, which is this one, we'll call this S, and we'll call this R, and you add 0.5 to it to get R. So shoe size plus 0.5 to get R. It's going to be one or the other. So if it has a, I mean, if you check this one here and you get a number, and then you check this one here and it's not the common difference, then you know it's not going to be that one, and then move on to quotient or ratio, whatever the book called it. But here I noticed, hey, they're the same. I mean, you really should be checking all of them just to be thorough with everything. But I mean, you can do that in your head here, right? You can see the difference between these two is a half. The difference between these two is a half. The difference between these two is a half, right? So you can see them pretty easily. Again, you're just starting with these. They're fairly easy ones. So there's your equation for it, pulling it out. Let's look at one that is, see, this one will be a quotient. Quotients tend to get big faster because you tend to be multiplying, and multiplication just increases things faster than addition does. So you should think of that. Yeah, Lyra, that's fine because that's what I've been doing in my head. If you didn't pick up on it, I'm trying to do it the way the book did. But yeah, you can do it that way because that's the algebraic way of doing it. Right, this here is your x value, this is your y value. These are all lines. They're going to fit y equals mx plus b. They're going to fit this. You're not going to have a b because it's just going to be a multiplication thing. So it's going to be some number, your common difference here, times x, and your common difference is going to be your slope. Or it'll be the addition one, which would be y equals b plus x. So, I mean, it's it's pretty dumbed down right now, but it's just getting you used to saying, okay, this variable here is going to relate to this variable here. Notice what does that mean? Notice something between 49 and 120 means notice relationships between difference. Where are you getting the numbers 49 and 120? Oh, I think I know what you're getting. Oh, yes, that is a thing. However, we're not getting that deep into it. You can get second differences, which is a thing, and that's a telltale sign that your function is a quadratic, which will be towards the end of the year in 8th grade. I think I understand what you're saying. Like here you might, like, hey, if I subtract these two, I get 1. This one's not a good example because it skips 4. Let me put 4 in. Right, you noticed, hey, this is 1, this is 1, this is 1, this is 1. See how that's going up by 1s? This is going up by 10s. This kind of common difference is a telltale sign that this is linear. This is a line. Which you don't have to get into. But we want to know how this relates to this. We want to jump between the two. So here we have a common difference of going this way. So like 20 minus 2 equals 18, and then you have 30 minus 3 equals 27, and 40 minus 4 equals 36. Right, and then 50 minus 5 equals 45. You will note this difference, right? You're getting 9s. Right? That is something to look for, but it's kind of a slightly different topic than what we're covering. This is called a second difference. Could it be r minus 0.5 equals s? I think g minus... It could be, yeah. r minus 0.5 equals s. See, this is where you get confused with your independent and dependent variables, because this is an inverse relationship. This does have a inverse function to it, meaning if I give you the y, you can tell me the x. And a lot of functions are like that. Most functions are probably like that. But based on the context is just going from everyday life, you probably know your normal shoe size before you figure out your running shoe size. So given that most people do it that way is the way that it kind of leans towards. But this is the same equation. I mean, you can, right, if I add 0.5 to both sides, I get r equals s plus 0.5. And that was the other one we had. Oh, 6 and 60? Yeah, it's still going to be, right, you're just going to add 9 to this. 6 minus 60 is going to give you that 54. You'll note these here are your multiples of 9. Right? So your second difference, that's a telltale sign that this is going to be a multiplication one as well, unless you want to do the common ratio. The common ratio, or the common quotient, sorry, is easier to figure out here though. So this has a second difference, but your book doesn't get into that. Here we're going to look at these numbers here. Right, you're going to look at these numbers here and you're going to ask yourself, are they the same? And no, they aren't. So in that case, you're going to go into, hey, let's find a common ratio. Or a common quotient. Right, common quotient would be 20 divided by 2 equals 10. 30 divided by 2 equals 10. 40 divided by 4 equals 10. Right, 50 divided by 4 by 5 equals 10. Here you have your common quotient, so you know that it's going to be multiplication. I'm going to multiply 2 by 10 to get to 20. So it's saying 2 times 10 equals 20. In this case, I called my 2 is actually called x, so this would be an x. And my 20 is my y. This would be a y. And then you would rewrite that nicely, which would be like that. But that's acceptable too. Right? All right. Give the homework a shot. If you have questions about the homework, let's save that for Monday, because I do have people who have questions about the test and questions about yesterday's stuff, and I am running out of time here. I don't want to take up your whole weekend. So give the homework a shot. If you still don't understand it, ask questions on Monday. We will take Monday to just clear up any questions we have so far. Your book kind of does this weird thing first. Due to the fact that you don't know algebra, it's kind of, well, you know some algebra. I might explain it to you algebraically later. But it's starting to get you into what's called a function. And a function is just the rule that says, how do I go from x to y? So this here would be your function. It would be written a little differently. It would be the function of x equals 10 times x. But it's the same thing. Right. Yeah, we'll go over the homework together Monday. So give it a shot, and then we'll do it together on Monday. Now, are there any questions about the test? Because I still have some people who are working on it. I don't have all of them back yet. Do you have any questions about the test? I know Anna had a couple at the beginning there. I'm not sure if she still has questions or not. She figured them out. But again, I didn't give you everything. Like number 2, how many hours in a fortnight? I don't think I gave you how many. Well, I told you that fortnight's 2 weeks. I'll give you the conversion ratios for it, Anna. I'm not going to do it for you. It's a test. But it says how many hours are in a fortnight, and it tells you that a fortnight is equal to 2 weeks. So it really wants to know how many hours are in 2 weeks. So you need to know how many hours are in a day. So we know 24 hours equals 1 day, and you need to know that there are 7 days in 1 week. So this here is the information that you should be looking up in order to solve that if you didn't already know it. So a fortnight, it is the 2 weeks. So a fortnight equals 2 weeks. 1 fortnight equals 2 weeks. I guess if you want to put that into the ratio, you can, but you can probably do that in your head. Can you have a third difference? Yeah, you probably can. I mean, yeah, you can. It's just you're not going to use that method to find it. No one's going to do that. You're going to be graphing things. It's going to be too complicated of an equation. You probably do both on 4. What was it? Catherine was 6. What is 6 about? So Mark McGuire, famous baseball player. So he hit 70 home runs. So we want to know how many miles. So you want to know how many miles is 70 home runs. And if you don't know anything about baseball, you have 4 bases, right? And you travel this path. Hopefully you know this. And it's telling you that this distance here is, I don't know how long, 4 bases with 90 feet between each base. So this is 90 feet. This is 90 feet. So what you need to do is you need to start with home runs. So you know that 1 home run equals 4 bases, right? Because you're going to travel all 4. 1, 2, 3, 4. You need to know that 1 base is equal to 90 feet, right? If I'm traveling the first base, I'm traveling 90 feet. If I'm traveling the second base, I'm traveling another 90 feet. Third is a third 90 feet, and fourth is the fourth 90 feet. So you should be able to do that. Oh, that's feet. Then you need to know that how many feet are in a mile? 1,280 feet equals 1 mile. So these are the ratios you need to know for that. For 4, you're doing both probably. Remember when you set up all your things, you multiply your numerators, you multiply your denominators, and you divide your answer. So you're going to multiply numerators. You're going to multiply denominators, my chicken scratch, and then you're going to get a fraction, and you divide to get the answer. Or you simplify it if it's a nice fraction. Any other questions? Well, it is 2 o'clock, so I am going to end it. Our math class is technically over. Um, we will not do anything new Monday. We'll just kind of go over our work um, and see if we have questions on it then. And we'll work from there. So with that, I will let you go. If you have further questions about things, I don't know, I might answer emails this weekend, I might not. Depends on how nice it is outside, I guess. Stay safe out there. I know things are starting to open up, but just continue your social distancing, things like that. And I will talk with you on Monday. Have a good weekend. Bye.